There's a silent, relentless force at work all around us. It doesn't roar, it doesn't shake the ground, but it is slowly and surely eating away at the very foundations of our world. It's an enemy that's hiding in plain sight, and today we're talking about corrosion. So let's pull back the curtain and see what's really going on. I want to start with this number. Just let it sink in for a second. $2.5 trillion. Yep, that is the bill the entire world gets handed every single year, simply because the stuff we built everything with is constantly trying to fall apart. It's a number so huge, it's almost hard to even think about. So to bring that massive number back down to earth, here's another way to look at it. 3.4%. That's the chunk of our entire global economy. Just gone. Devoured by the constant fight against our most essential materials simply breaking down. It's like a massive, unavoidable tax on progress, and it's levied by nature itself. So, to really get why this costs so much, we have to understand what it even is. What is this process that's quietly draining trillions from the global economy? At its heart, corrosion is just chemistry. You could almost think of it as the universe's ultimate recycling program. See, we take these refined metals to build amazing things, and from the second we do, nature is working to return them to their original, more stable, earthy state. Like rust. And what's wild is how simple the trigger can be. This diagram shows it perfectly. All you really need is a drop of water on a piece of steel. That little drop creates a tiny electrical circuit, basically a microscopic battery, with a positive and negative end. And that tiny bit of electricity is all it takes to kick off the whole process. But here's the really crucial point. Not all corrosion is created equal. That familiar reddish-brown rust you see on an old fence? That's just the most obvious kind. Some forms are way more subtle and a whole lot more dangerous. Let's break it down into two main types. On one hand, you've got uniform corrosion. Think of this like evenly sanding a piece of wood. It's slow, it's predictable, you can see it happening. But then you have localized corrosion. This isn't sanding. This is like taking a tiny drill and boring a deep, invisible hole. It's fast, it's hidden, and it can be absolutely catastrophic because you might not see it coming. And this right here is a perfect example of one of the worst kinds, pitting corrosion. From the outside, a pipe or a tank might look almost perfect, but underneath, these tiny, deep pits can punch right through the wall, even though 99% of the metal is totally fine. It's this sneaky, hidden damage that gives engineers nightmares. Now, this kind of localized attack can lead to something even more alarming. On the left, you see a pipeline that failed, but on the right, that's what's happening on a microscopic level. Those aren't just rust spots. Those are tiny cracks, spreading like veins, deep inside the metal itself. This is something called stress corrosion cracking, or SCC. It's a deadly combo. You take a metal that's under tension, like a pressurized pipeline, and you put it in just the right corrosive environment. The result isn't a slow leak, it's a sudden brittle snap of a material that's supposed to be strong. It is one of the most unpredictable ways for things to fail. So when you've got all these different ways things can fail, from a slow, even rust to these sudden, invisible cracks, it's no surprise that the impact on our global infrastructure is just massive. This isn't some small niche problem. It hits pretty much every major industry we rely on every single day. I mean, just think about the scale of it all. For oil and gas, a corroded pipeline is a potential environmental disaster. In transportation, it's the salt on winter roads eating away at your car, your bridges, and railways. In construction, the very steel that reinforces our concrete is at risk. Power plants, water treatment facilities, the list just goes on and on. It really affects the safety of everything, from the bridges you drive on to the water you drink. And the stakes are incredibly high. As this research from 2023 states very plainly, this isn't just about money or maintenance. Unchecked corrosion leads to catastrophic failures, with really serious consequences for people's safety and for the environment. Okay, so the problem is huge, and the enemy is relentless. So what are we doing about it? Well, the good news is we are not helpless. There's an entire field of science and engineering dedicated to this fight, to slowing down the decay and protecting all of our vital infrastructure. The battle is really fought on four main fronts. The most common one is the simplest. Just put up a barrier, like paint or a zinc coating on steel. We also use special chemicals called inhibitors that form a protective shield right on the metal's surface. For massive things like pipelines, we use a clever electrical trick called cathodic protection. And of course, sometimes the best defense is a good offense, just starting with the right material, like stainless steel, from the get-go.
So where does all that money actually go in this fight? Well, this 2014 study on corrosion costs in China gives us a fantastic snapshot. And I mean, you can't miss it, right? Just look at that huge blue slice of the chart. Over 66%, a full two-thirds of all the money spent on prevention goes into one single category: coating.
And that's really the bottom line here. For all the advanced science and high-tech alloys we have, our #1 weapon in this multi-trillion-dollar war is, more often than not, a simple layer of paint or some other protective coating. It is our absolute primary line of defense.
Which brings us to the core reality of this whole situation. This isn't a war we can ever truly win. It's a constant, never-ending battle of containment, of management, of endlessly pushing back against one of the most fundamental forces in nature.
At the end of the day, corrosion is just nature trying to get back to a state of balance. We build these incredible things from refined elements, and nature immediately starts the slow, patient work of taking them back. So as we innovate and engineer better and better solutions, you have to ask, right? Are we really solving the problem, or are we just getting more sophisticated at delaying the inevitable?